Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 102, I chat with Renato Pellegrini about his Absolute 3D audio technology. So stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded March 12th, 2012, episode 102, Absolute 3D Audio. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, online editor of hometheater.com. My guest geek this week is Renato Pellegrini, who is the co-founder of a company called Sonic Emotion, which has developed a very interesting audio technology called Absolute 3D. Hey, Renato, how are you?
I'm excellent. Thank you for having me on the show today.
Well, thank you so much for being here. You have the distinction of being my very first guest from Europe. You are sitting currently near Zurich, Switzerland.
That's true. I'm heavily impressed. Thanks for giving me that honor.
And just goes to show you that Skype will work anywhere. So this will be great for other guests in the future who are far away, and as long as they're willing to stay up somewhat later than usual or earlier than usual, then it should be fine. It's not too bad where you are, right? It's like 9:30 or so?
It's like 9 p.m. 9 p.m. Yeah. Perfect timing for me.
Excellent. Wonderful. Okay, good. Well, listen, before we start, I want to make sure everybody knows that those who are tuned into the live video stream can email questions, or rather put questions into the chat room if you're logged into the chat room at irc.twit.tv. I believe you can also get there from the live stream at live.twit.tv. And if you have any questions for Renato, you can post them on the chat room, which I am following, and I will pass along as many as I can. So you have a PhD, I believe, in acoustics. Is that correct?
I actually did my PhD in virtual audio, doing virtual audio environments, talking a lot and studying a lot about how human beings localize. How can we actually tell 3D sound?
Right. So psychoacoustics, in other words.
Exactly. Yeah. True.
So tell us a little bit about what got you interested in that subject and how it led you to where we are today.
When I started my career, I would say, as a professional electrical engineer, I was having the chance to work for Studio Professional Audio on a mixing console. And that was at the time where surround sound just started to lift off. Everybody was fancy about surround sound recordings in 5.1, and people would play around sound not only in front of you, but also to the sides and behind you. At that time, I had the chance for Studer to do my PhD and learn more about how human beings actually perceive all that information, because at the end of the day, we only have two inputs here, sound pressure meters. They're one-dimensional, and from those, you can tell all 3D.
Now, that brings up an interesting point that a number of people have expressed to me, which is, hey, we've only got two ears. Why do we need more than two speakers when criticizing a surround system? And I answer, well, yeah, we only have two ears, but we have the ability to discriminate where a sound is coming from just about any direction.
That's absolutely correct. And one good way of recreating a virtual environment is actually using headphones. So you just feed the proper signals to your left and your right ear, and you are able to recreate a full three-dimensional sound field surrounding you. However, we don't keep our ears shut and still all over. We move in space, we explore spaces, and all that information is taken into account by the brain system for your information about your spacious environment, your room information, how large a room is perceived, how spacious it sounds, how reverberant it sounds, and how distant sound sources are. So for all that, you don't have two still ears. You have ears moving in space in reality.
Right. Now, Tom Holman has said that the human ability to discriminate the direction from which a sound is coming is more acute in front of us than behind us. Would you agree with that?
That's actually true. We have an accuracy of about 1 degree in front of us, which is enormously accurate.
Mm. And I suppose that's probably because in the way in the distant past, we had to know from which direction the growl of a tiger was coming or whatever in order to avoid being eaten.
That's very true. Yeah, we tend to move towards our enemies and face them, and therefore we also have more means to actually accurately tune our ears because we can match visual cues with audio cues, which allows you to actually get more accuracy in the front than you would ever get in the back, where in the back you have never any match with any visual item.
Of course, I had never thought of that before. That the brain will, in fact, combine the information from the eyes and the ears to give us an even more accurate picture of where a sound is coming from ahead of us than it would behind us because we don't have eyes in the back of our head.
We're not born with that. We actually need a couple of years to train our ears to get that accuracy. So it tends to be up to the 7th or 8th year of a child. They will not have that localization accuracy of older children or adults. Yes.
Oh, I didn't realize that. It's not inherent then. It's a learned skill.
Yes. Therefore, be careful with children. They can't tell where from the car is approaching you. Not to the accuracy we can.
Ah, therefore the admonition from parents, don't step out in the street. Look both ways. Okay, very good. Very good. So with that in mind as your background and as your field of study, you came to develop this technology that Sonic Emotion is now offering to the world called Absolute 3D. What led you to this? Why did you decide to develop this? There are other sort of 3D simulation algorithms out there. So maybe tell us a bit about how you came to develop it and why you thought it was important and how it differs from maybe some of the other ones out there.
One of the most important facts about Absolute 3D, how we call our technology nowadays, is a technology called Wavefield synthesis. Now, Wavefield synthesis recreates physically accurate wavefronts in space using a high number of loudspeakers surrounding the listening area.
Now, we have a picture, by the way. Before you go on, let me just say that our engineer, John, can put up WFS 1 and 2 and show us an example, a graphic of what you're talking about here.
Exactly. So on the left side, you see that violin emitting typical sound waves depicted by these bluish curves. Mm-hmm. What we do with Wavefield synthesis is we take a number of loudspeakers and we recreate those wavefronts by simulating, by each and every loudspeaker, just a little portion of that total wavefront. Now, wherever you are in the listening space on the right side, you will not hear the loudspeakers, but you will hear the source, the original violin playing at you, which is a very, very strong feature.
Right.
If you can do this with two signals, so instead of just one violin source, you take two signals, like in the next image, you will have a left and a right signal approaching any listener in the listening environment. And that's a very simplistic setup for a stereo listening environment. Now, anybody in the listening area will have its left signal and its right signal perfectly tuned in to his very head. Wherever you are, the sound field will move with you, and you will get this sensation of you can't leave the sweet spot.
So I'm looking at this image, and I'm seeing the right and left speaker wavefronts, if you will, and they're being reproduced by this larger number of smaller drivers. What then is the real difference between the wavefronts coming from single speakers and the wavefronts coming from a bunch of little speakers?
When you approach your left loudspeaker, and those of you who hear me now on a stereo system, if you just approach your left speaker now, you will hear my voice coming out of that very speaker. If you approach your right speaker, the whole thing will shift towards the right speaker. So it tends to move the sound sources with you moving, and it tends
as you were
to
talking about earlier. Yes, as you were talking about earlier, when you move around an environment, what you hear changes, and so this is an example of that.
Exactly. So in stereo listening, you usually need to sit in between the two loudspeakers, and only if you're in the very center between left and right speaker, you will have a good stereo setup. That spot is called sweet spot.
Right.
With Wavefield synthesis, you don't hear the single speaker, but you hear plane waves approaching you from left and right side. And wherever you are, the direction of incidence of those plane waves will remain to be the same. So you can move, but the sound image will not change. You will still have your left and your right signal.
This reminds me of another system you might have heard of called Eosono, which, I'm sorry, go ahead.
Eosono is actually a technology company that came out of the very same European research program originally. However, they are exploiting now Wavefield synthesis just for high numbers of loudspeakers. Sonic Emotion has taken that technology from that early stage towards a technology which can be used even in consumer end applications with far less loudspeakers. So today, what we can do with Absolute 3D works with as low numbers as 6 loudspeakers.
So you need at least 6. I know the Eosono uses hundreds.
That's true.
So you're coming back with merely 6 to get much the same effect.
Exactly. And even better than that, these 6 loudspeakers don't need to be in different boxes. They can be in one device. Actually, all the products we are showing today in the consumer field have all these drivers sitting in the same device. Can be a soundbar, can be a docking station, can be a TV, whatever you like. But it means that a consumer will not need to wire up many loudspeakers as they used to do for 5.1 or surround systems. So it's much easier to set up and a very convenient way to actually get 3D sound in a real environment.
Now, how do you then, I can see how you would reproduce the sound of an individual instrument or a pair of speakers through this technique, but how do you then get it to wrap around you or go above you, which I have actually heard in some of your demos?
One very important aspect of what we do nowadays is we call the whole technology, which was phrased Absolute 3D, we call it sound field control. And
now we have a graphic for that as well. So let's see if John can pull that up while you're talking about it.
Oh yeah, excellent.
Yes, there it is.
Oh yeah, that's perfect. So the first thing we do when we take in a recorded sound, let's take some music just for simplicity. Music today is recorded in standard formats. And just for simplicity again, let's assume that music to be stereo. The first thing we need to do is to do some spatial analysis, which means that we take the incoming sound and we distinguish between sounds that are localizable and sounds that are meant to be ambient sounds, like reverb, like room information, sound that just makes you feel comfortable in the environment, whereas the distinctive instrument has a certain location. By doing this distinguishing, you can actually treat the different sounds differently. You can take the localizable part and give it a very spotty position, whereas all the immersive part, like the room information, will be fed into your listening environment in a way that you get a spacious, immersive feel of your sound environment. And that's what makes you feel, oh, I'm in this room where this instrument is playing. It's not like a stereo system where everything is between your left and your right loudspeaker and nothing else than just there and a little bit behind that.
So what are these four elements? We've talked about one of them, which is Wavefield synthesis. How do the other three enter into the picture?
So the spatial analysis actually makes this transformation from the incoming, usually stereophonic input, to your 3D sound representation. So at the end of your spatial analysis, you have localizable sound sources with distinguishable positions, and you have ambient sound. The ambient sound is just diffused into the room such that you can't tell localization of that sound source. It's just diffused all over the place. And the localizable sound sources are reproduced by Wavefield synthesis to the distinguished spots of where they should come from. Now, on top of that, we also use psychoacoustics because we have learned it's much more efficient to trigger or stimulate the right sensation for your ears to get a certain distance or to get a certain localization. If you just recreate the physics of a real environment, you do a lot of rendering or algorithmic calculations that are not heard by the human being. If you take psychoacoustics into account, you can do exactly what's needed to recreate the sound source at this specific spot, at this specific distance in a room of given size X. Therefore, psychoacoustics helps us for two things. First of all, we can keep our reproduction calculation cost low. And secondly, we can assure that whatever we do, we will not recreate artifacts that are heard as disturbing noise, jitter, or phasiness, which you might hear in other solutions, where if you move in space, it goes like strange noises appear. And I'm sure you have experienced that with other technologies, where whenever you move out of the sweet spot, it becomes really jerky and not easy to tell what you're actually listening to. So psychoacoustics helps us to recreate sound fields in a proper way that you're even allowing yourselves to move in space and walking about. And last but not least, last but not least, on the left side of the drawing, you saw physical acoustics. So whatever loudspeaker or driver you're using, that loudspeaker will be capable of certain things. It will have a frequency response. It will have some distortion at some level. Better quality loudspeakers will have less distortion, but still they will have distortion at certain levels. And using the physical acoustics and the know-how of the real device, even the baffling of the real device in space, we can optimize the sound among all loudspeakers such that we use each and every single driver at its best, not feeding it with signals that will bring it into distortion, not going over that threshold where it becomes just bad in sound quality, but using all of them in jointly to recreate, for instance, low frequency waves with a higher surface. So instead of just trying to create low frequencies with one driver, like you would have in a standard 5.1 setup with a multi-way speaker, we use all of the drivers for all low frequencies.
Even
so
the tweeters?
Surface, well, we only have broadband drivers in most of our designs. And those broadband drivers, you can use them all together to recreate a higher surface of moving air. And if you do that correctly, in phase and accurately in level, given the spacing they have, you can recreate a really good low-frequency wave.
Because the combined area of vibrating area of several drivers is larger and can therefore recreate lower frequencies.
Exactly. And even more than that, you can overcome the issue to some extent that the single driver actually always will have a distinctive directivity pattern.
Yes.
The smaller the driver is, the broader it will be, most likely. But we can control the directivity of the total device by adding the different signals the way we want it. So if we want something very directive, like very sharp like this, you would use the drivers in a manner that you will create beams. or if you want to have something very broad, you could actually add the driver signals in a way that you would get a total directivity, which is almost omni.
Mm.
So
now
again,
yes, go ahead.
Sure.
No, I was going to say, please finish your thought.
Okay, so with that said, we have all control of drivers, which usually in a normal loudspeaker in a stereo setup are just fixed by the physical design and the acoustics of the given box.
But with your system, you can use the physical parameters, the box that the drivers are in, the characteristics and capabilities of the drivers themselves, and use those in a way that in some sense transcends the physics of the box and the drivers and so on that you're working with.
We don't overcome the physics. They're still there and they're working nicely for us. However, we use them in a way that they properly match our goal or our aim of reproducing the sound field.
Yeah.
If you do that correctly, you end up not hearing the loudspeaker, but you hear the sound field emitted by the loudspeaker. Mm. So in the image you saw beforehand, if you do everything right, you will hear the violin and not the loudspeakers in front of the violin.
Right, right. We had one more slide I wanted to show, which is a comparison of the sound field that one gets with a traditional 5.1 system compared to the sound field one gets with this Absolute 3D, which is 5.1 versus Absolute 3D. There it is. It's kind of wide. So I'm not sure we can see it all.
Okay, so you on the left side in the greenish image, you see like 4 of the 5 speakers in the image. And on the sofa, on the lower left, that's where you would need to sit to experience a more or less proper 5.1 system. Actually, the sofa would need to be in the middle of the room. That's one of the old jokes of the ITU setup. And people tend not to have the sofa in the middle of the room. So you're very restricted in that setup where you should actually be seated if you want to experience perfect 5.1 surround sound. Mm-hmm. Whenever you're closer to one loudspeaker than to all the others, you will tend to hear that very loudspeaker over dominant, and you will hear the sound coming out of that very loudspeaker. On the right side, that was the reddish image, you can see that from one single soundbar just below the TV set in the right part of the image, I only see part of the image, so it's sort of difficult to see it there, that reddish glowing box, that's the soundbar, and it will fill the whole room. And you will hear sound sources not only from that soundbar, but from all over the place using Absolute 3D technology.
Now, does the Absolute 3D technology rely on reflections from the walls, ceiling, and floor to achieve a greater sense of immersion?
Yes, but only to some extent. We use the environment in the room just for the ambient sound parts, not for localizable sound parts. Mm-hmm. And this allows us to actually recreate a proper sound field without even calibrating for a given environment. If you compare our technology to, for instance, what Yamaha uses in their sound beamers, they use a technology which heavily relies on reflections on adjacent walls, even to the back and even to the ceiling.
Yeah, a lot of simulated surround sounds use exactly that technology.
Exactly. To make that work, you need to calibrate the system for one single listener spot. There are technologies out there where you can calibrate for 2 or for 3 spots, but still, there's no way you could actually move about in the whole space and enjoy your sound field wherever you are. Mm-hmm. And that's what makes us different from those technologies.
Mm-hmm. So you could use this such a soundbar in, say, a room that didn't have walls. Like there are a lot of situations where there's the area where the home theater is open to another part of the house, or there might be half a wall there to the kitchen or something like that. And your system, you're saying, will still be effective in such an environment.
Absolutely. The only thing we like to see is that there is some enclosure, like we have at exhibitions. It's open walls, but we do have some enclosure just to shield off some of the noises that might be surrounding you and to allow even small devices to fill a room with a reasonable amount of sound pressure.
Yes, I've heard your demo at a couple of CES shows, and there's a lot of ambient noise there for sure, and you do build a little kind of three-sided room in which you do your demos, and it's open to the show floor, of course, but once you step inside that room, the demo is pretty effective.
Yeah, we always see customers approaching us from pretty far and already telling that's something very special. That small device seems to create that sound. And then they approach us, they come in even closer, and they really get impressed once they're in front of it, experiencing the whole thing. So
right.
That's actually one of the nice things about our technology, that it's so easy to explain once you hear it. When you experience this sound field, it's so much different from anything you know from stereo sound. It's very impressive.
Yes, and that's so true of just about everything in our business is, we can talk about it all day, but really the best way to learn about it is to experience it. So I do hope that some people out there get a chance to do that. And there are a number of products now, sound bars anyway, that are starting to come into the market. Why don't you tell us about some of those?
Oh, yeah, I'm happy to do so. So in the US market, we have several brands already showing products on stock, on store, like, for instance, Audio Source has one product out on store, two more coming this year. Can't talk more about those yet, but one product, the S3D60, is already there and selling heavily on Amazon. So we're in the top 10 all over the time since 6 months, and a very successful product, very successful launch. It's a soundbar device. It serves your flat screen to become less flat in sound. So you have a big sound with a flat screen. Good combination in my view.
Absolutely.
And it comes in a very nice form factor, very easy to plug. There's just the stereo signal you feed into the soundbar, and you're up and running. No calibration, no extra wiring, no loudspeakers all over the place. A very easy setup, and you can experience absolute 3D just there.
Now, I must admit, I do have one of these Absolute Sound soundbars that I've just now started to play with, and I do wish that I don't think there is such a switch or a control, but I wish there was to turn the Absolute 3D on and off to hear the difference between having it there and just having a standard normal soundbar.
I do understand that request, and some of our soundbars in the marketplace do have that switch. We call it the bypass. So you can actually bypass the functionality of Sonic Emotion Absolute 3D. For instance, the higher soundbar that's just about hitting the market, so it has been launched at CES this year. It's the SVEV40 3D, and that soundbar actually has this type of bypass functionality, which people will at least use to show off what cool device they bought. Because
exactly.
They will turn it back on quite shortly.
Oh, of course. Go ahead.
There are more soundbars and different form factors as well from a brand called Lenco, which becomes more and more prominent also in the US, I have been told. Lenco has shown 3 devices using our technology so far in the marketplace. There will be 2 more coming up this year, 2 of which are towers. So you have just one single speaker looking like a normal stereo speaker. There was a DVD player in one of those, and you can create and recreate 3D sound just from that very one speaker. It also has...
Hang on a second now. I got to ask you this. That speaker, if it's a tower and it's standing upright, the array of speakers is vertical, not horizontal.
No. So, that's just a fake. So the loudspeakers are still on a horizontal plane. So that's true. And you're perfectly right in saying this. And thanks for pointing that. All the loudspeakers always need to be in a horizontal plane. So for the tower speaker, we do have a subwoofer below. And then there is an arc of 6 loudspeakers, just 2 facing front and 2 facing each side.
Okay. So in other words, and that's what's happening in the tower. I can imagine seeing almost like a pedestal and then some sort of bar of speakers sitting on the pedestal. Well, that's not what you're talking about, right?
No. Easiest way to experience what I'm talking about is if you go to www.sonicemotion.com, we always show our latest products, which means we show our brand's latest products. The IPT6 is one of these tower speakers that is showcased there.
Excellent. We'll go take a look at that. Beatmaster in the chat room asks, is this technology for the mastering recording process, or is it a surround mode for receivers, or really does it need to be built into a specific, I think what you're telling me, and tell me if I'm right, that you need to build it into a specific box with at least 6 drivers in a horizontal, more or less, configuration. So it wouldn't be a surround mode in a receiver, would it?
No, couldn't be that, because we need to know exactly where the loudspeakers are. The only way to actually get absolute 3D in your product is we sell a chip solution, a one-chip solution to our brands, and brands are enabling to use that technology in their products. So we're helping them and offering them the service to get them to work in their very product. There's some measurement involved, but at the end of the day, end customers will buy products that just have a small Sonic Emotion Absolute 3D sticker on that tells them, okay, this very product works with Sonic Emotion 3D sound or Absolute 3D.
A number of people in the chat room are asking about how this technology compares with Gen Audio's Astound sound. Are you familiar with that technology?
It's a technology that I'm not that strongly familiar with. It does aim at similar things. We just feel that the sound area where you can listen to stuff is much wider with our technology. So wherever you are in the room, you can experience 3D sound. And at the end of the day, we have very good ratings when it comes to the sound quality of the devices at all. So
I will say this, that Astound Sound uses a different paradigm. They use a pair of loudspeakers in a normal stereo configuration or headphones to achieve a 3D diffusive type sound space, whereas you're using Wavefield synthesis with a series of horizontally arrayed drivers. So that's one difference. It'll be interesting to do some sort of comparison at some point to see how they compare one to the other in terms of this 3D audio.
I absolutely agree. And I think it's very important not just to diffuse sound all over the place. You still want to have localizable sound sources very accurately reproduced in space. You want to have a sound field that's very transparent so you can pinpoint single instruments that are important, but still you get this immersive sound all over the place. And by the way, this is not only used for music listening. Many people will watch movies or play games using that technology. And think about how important it is to hear your enemy from the exact position he's approaching you so you can win that game.
Right. So there would be another great application for it. I mentioned headphones and Astound Sound a minute ago, and you have a headphone technology that's related to this as well, which I want to get to next. But before we do, I want to take a moment to thank our sponsor for this episode, which is Netflix. Now, Netflix, of course, lets you stream thousands of TV episodes and movies directly to your TV, to your home theater, to your computer, using just about any device these days. TVs have the Netflix app directly, Blu-ray players, gaming consoles, iPhones, iPads, some Android phones, I believe, as well. Just about any device, like your computer, of course, can, and in any case, for one low monthly fee, you can get anything you want streamed directly to your TV using Netflix. You can even start on one device and finish on another and get all this for a low monthly fee. I think it's $8 or $9 a month, and unlimited streaming. And I use it all the time myself to access content that may not be on Blu-ray, or it may be, but it would be kind of expensive. And I don't necessarily want it in my permanent collection. You know, people like to collect physical things, but after a while you run out of storage, and there's many more things out there I want to look at than I can store in my library. So I find Netflix to be invaluable for that. For our TWiT listeners, of course, Netflix is offering a 30-day free trial to check it out, and I sure encourage you to do that. Just go to netflix.com/twit. Be sure to use that URL when you're signing up for your 30-day free trial. That's netflix.com/twit. And we sure thank Netflix for their support of the TWiT network and especially of Home Theater Geeks. So, Renato, you've recently introduced a version of this Absolute 3D technology for headphones called Headquake. I love this name.
It's very impressive. Let me show you, studio. Headquake is one of the good ways to experience Sonic Motion Absolute 3D sound just on an iPhone. So you can have this very nice application which actually sits on top of your iTunes library, and you can listen to anything that you would have in your iTunes library through Headquake. You can have all the search capabilities by artist, by song, by album, or composers, or any more, like in your normal iTunes app. However, here you can experience your sound on the device in 3D. So put your headphones and you will experience your stereo sound system like it would be on real loudspeakers in a real room. And more than that, you can actually control the sound field you're listening to. So you can make it more wide, or you can actually decide to have your loudspeakers more in front of you. You can have the sound to be more ambient or less ambient. And those controls are available for each and every type of music you're listening to just on your iPhone.
Wow. So the first question that comes to mind is that you have, instead of having a linear horizontal array of drivers, you have two drivers, essentially, one going into each ear. Isn't that sort of contrary to the technological underpinnings of Absolute 3D?
You're perfectly right. The technology in the background we're using here is not exactly the same. We're using some so-called binaural technology, which is a technology known since the late 70s to allow you to recreate the sound field all over the place just by feeding the proper signals to your very ears.
SoCal Ray Jr. in the chat room, getting back to Absolute 3D, has asked, how do you direct discrete sounds if you're only using two-channel analog audio input?
Well, one of the very important steps there is to actually analyze your incoming sound. And as we know, the recording was done in stereo. You can tell by a psychoacoustic model where a human being would hear a sound. If the signal is exactly the same in both signals, in the left and the right signal, you would hear that sound exactly in front of you when you listen to a perfectly set up stereo system. We take that information into account and we recreate that very sound source or that part of the incoming sound just from in front of you. And we would do this for any incoming sound, deciding, is it localizable? If yes, where is it coming from? And just from that very information, we recreate this three-dimensional sound field.
Pixel asks, so I can use this system to play surround games? I think the answer is yes.
Yes, absolutely. Go for it. You win.
I know that the audio source device soundbar has an optical input, so you can input Dolby Digital or DTS, a 5.1 channel sound source into the device, right? And will that then recreate the 5.1 more or less experience?
Yes. You're saying it exactly correctly. We don't aim at getting perfect localization to the far left back and the far right back. With a soundbar just in front of you, what you will get is very decent immersion to the sides of yourselves, but you won't get a perfect localization to the far left or far right. If you want to recreate that type of a perfect 5.1, 7.1 system, the way to do that is to use two soundbars, one in front, one in the back.
Oh, there you go. iPad 63141 asks, can it be used with regular surround systems also, with a real 5.1 system? I would think not.
Not what we sell on the consumer end. Our pro systems, they actually could do that, and you could tune in loudspeaker positions for each and every loudspeaker, but that's on a different scale of cost. Although we have some customers that would even buy into that for their home theater sound system to get the best they ever could.
Right. We're going to get to your pro applications in a minute, because those are also very interesting. I just want to run through a couple more questions from the chat room. Feld in the chat room asks, does Absolute 3D need specially encoded source material? I think the answer there is no, right?
Exactly, and I'm very happy to say it's no. You can use whatever you have, and most importantly, nowadays, people, most of the time, they will rely on their mobile devices, be it an iPhone, be it an Android phone, to store their music, to store their movies. People are going to YouTube, and most of that content is just simple, plain stereo. Now, what Absolute 3D is doing for you, it recreates this 3D sound impression, even though the incoming format was just simple, plain stereo. And that's where the true benefit of the technology comes into everyday's life. In everyday's life, we don't listen to surround sound. We tend to be lazy and just to put the stereo tracks in an MP3 on our iPhone. We're happy with that. And just having that is enough to experience Absolute 3D wherever you are. With Headquake on the go, or with any docking station wherever you plug your device.
Now, you said, I think earlier, that you didn't need necessarily a lot of processing power to do this. And yet it seems to me that if you don't have something pre-encoded and you're analyzing in real time, essentially, with a little microchip, which sounds are directional, which are not, beaming them in the right way, and so on and so forth. That seems to me that it would require a fair amount of processing power.
There's still quite a bit of processing costs involved. I'm absolutely agreeing on that. What we did is we recreated a full-blown true ASIC to minimize the needed silicium and getting the costs down to a consumer level that you could really afford. And yet
it needs to be tuned to individual products, right?
But just once per product. So there's no calibration step for the end consumer. It's just one step that we need to do for a product when it comes to defining the very product in production. Gotcha.
John, our engineer, did find a picture of the Lenco IPT6 tower. Let's take a look at that. Just want to see here. Oh, okay, so it's not a real skinny tower.
No, it's a very nice tower, actually, with a docking station off top of it, as you can see, and some controls to operate. It also has an alarm clock, so fully featured with radio inside. And as you see, what says there below is just one of the rewards we got. It got a sehr gut, which is German, and says excellent in terms of sound quality. On a scale from 1 to 5, 1 being the best, we received a 1.3 for the sound quality of that very device. So we're really proud to see this product being showcased and being tuned, taken and shown to be a very good product.
Yes. Now that is available in the U.S.?
It should be available in the U.S. Yes, Lenco has started its distribution 2 years ago, and you can find it if you just Google it on your U.S. environment. You will find stores that actually show Lenco products.
Mm-hmm. Well, some people in the chat room are asking what other companies have released products. We've talked about Audio Source, we've talked about Haier, which is Haier, and also Lenco. Anybody else that you can mention?
Very cost-effective would be Kobe in the US. You have a CSMP 88 in the US that is a soundbar, very easy to use, $100 around on Amazon, so very easy to buy into that one. There are more coming up this year, specifically brands that have bought into our technology, but at the same time, these brands we are already showing now in stock have shown interest. And those A brands tend to have a little longer until they have final products in store. However, we are happy to announce that some of them, including Japanese brands, will show products later this year.
Excellent. Well, I'm looking forward to that. John, our engineer, asked a question. What about audio encoding in older 3D audio technologies like Q-Sound? Any relationship there, or is this just a different direction altogether?
That's sort of a different direction. I say the following. Whenever something is encoded in a format that a human listener would perceive well, if he would sit in the proper setup and environment, our analyzing step would do well as well. Because the first step we do is based on a perceptual model of human hearing. Now, if human hearing is stimulated correctly, we also recreate the 3D sound field correctly. In that way, we're compatible with pretty much any format you input. You could even take binaural signals at the input, and we still recreate them over loudspeakers pretty much correctly.
I'm going to actually, next week, as I will announce at the end of the show, my guest is going to be Bob Schuline, who's going to be talking a lot about binaural recording and playback. So that'll dovetail nicely into what we're talking about here today. Let's see here. I'm just trying to see if there are any other questions. F-Loop asks, is the soundbar market big and growing? I think the answer there is yes.
Yes, it is. If you look at customers, they tend to dislike any cabling hassle. They tend to dislike more and more of these loudspeakers. And soundbars have become more and more requested items in the marketplace, especially in the US. Now, when it comes to good sounding soundbars that would even recreate a better sound field than some of these cheap 5.1 small boxes type of things,
sure,
they actually are growing really intensely.
I was going to ask you about Headquake, back to Headquake app. Is that only on the iPhone or is it also on Android?
I'm very happy to announce that Android version will come later this year. So I think it's Q2 that we will be able to show also Android phones using Headquake. iPhone just released a new version of the device today. Should be short the next days that Apple will release it for public use. It's a 99-cent buy-in, so it's a very easy and cost-effective way to learn about Absolute 3D and what it can do to you in everyday's life. Further than that, not only we will show our technology on different phones and different OSs, also will allow our iPhone app and the Android app to have different settings for different headphones.
So you'll be able to tune it for the
quality.
Particular headphones.
Exactly. So whatever you have in everyday's life, I won't show any brands here. Let's say you have a specific device of headphones, you can actually tune it to the very headphones you're using to get the best sound impression you could ever think of for that very headphones. And we're partnering in a B2B level with many headphone manufacturers at this time to actually allow themselves to showcase their excellent headphones together with our 3D sound technology to form a nice package.
Fantastic. I need to get you in touch with Tyle Hertzens, the editor of our sibling website, innerfidelity.com, and he covers almost all headphones, certainly personal audio. So I really would like for him to get access to this app and check it out himself for his website. But we'll talk about that offline.
Love to do so anytime. Sounds like I get less and less sleep next days.
Well, as we in the States got an hour's less sleep over the weekend with the daylight savings time. I don't
complain.
No, I'm not complaining too bad. No. I wanted to spend the last few minutes we have here talking about the professional applications, which you mentioned a little earlier. You have a processor box that you have made available to commercial installations and so on. And in those cases, I think you're doing something a little bit different. We have a few pictures of some of the installs that come from your website. For example, at Cannes in France, which I think is the theater that they use for screening movies at the film festival. Am I correct?
Very true. Yes, yes. So for this type of installations, we use a device called the Wave 1, which allows installers and professional sound engineers to recreate the sound field all over the place. This type of hole you see here, normally you would just be able to feed a simple mono path to assure everybody would at least hear what's going on stage. If you just try to feed stereo in this type of environment and somebody sits on the right side of the hall, they would not be able to tell what's going on the left speaker because they're just simply too far away and sound attenuation would be too strong. So with our technology, you're getting back this surround feel and this even stereo feel in this very hall by recreating the sound field all over the place.
You can see on the stage there's a line, an array of individual drivers, and I assume that that's what you're using to recreate the sound field with this Absolute 3D.
Absolutely true, yes. And in contrast to standard Wavefield synthesis, our home technology allows us to have large spacing among the different loudspeakers. When you go to the textbook and the university reading of Wavefield synthesis, those spacings for loudspeakers would need to be very, very small, like 18 centimeters between two loudspeakers, which makes it not useful for professional applications because you can't build loudspeakers with SPLs that high in those small form factors. So with our technology, we're allowing ourselves to use standard loudspeakers, which are used in Pro, and placing them side by side to recreate a total sound field that's absolutely amazing. You can recreate sound sources that are moving in space. For instance, with the position of an actor, we have systems where a laser tracker will take the movement of an actor on stage and will actually follow the sound with the actor's movement on stage, stuff like that. So that's really fancy stuff.
Yeah, that's extremely cool. A couple other pictures I found on your website was Detmold Conservatory, which is, I think, a music conservatory in Germany.
Yes, that's in Germany. That's one of the largest spaces we have equipped with our technology. It comprises a hall of about 500 seats, and we have more than 400 loudspeakers built into that hall. Now, next to just recreating sound sources in space, we can also alter the reverberation time of that hall from a very low, fair 1.3 seconds up to 5 seconds of reverberation time in that hall.
Wow,
now, if you go back to the image, you see on the front right, you see an organ. It's a good quality church organ, and you can tell if that organ is placed in an environment of only 1.3 seconds of reverberation time, it will not sound that expressive. However, with the church environment of a real long and reverberance, this becomes a very strong effect. Now, the cool thing about that system there is, you're right to say it's actually in a school or a university to train world best sound engineers and tone meisters. Those people who actually put microphones in space to do the best recordings you could ever think of. Now, with our system, the teachers can tell them to reposition their microphones just because the hall has changed by the press of a button. And they need to use their ears, tell how this sound will change, and reposition their microphones accordingly.
That is really cool. Another picture we have is from Beijing. It's the NSTM. Now I've forgotten what that stands for.
It's a sort of a technical museum where you have an interactive setup in cinema. So each and every seat in the cinema has a joystick equipped. And this means that each and every watcher or listener in that environment will be able to position and play with one character on screen. Now, this will not only move the visual character, but it also will change the sound of that character in space. So it's all about fancy multiplayer games that you can play in that environment and have sounds and images move all over the place.
And I was wondering about
hide and seek.
I was wondering about that because if each chair has its own joystick and everyone's controlling the sound field, I mean, wouldn't that end up as being a big mess? But what you're saying is that each chair has control of one character on the screen and the sound that is associated with that one character.
Right. It's like you will control one instrument of an orchestra, and you can position that very instrument or that very part of the whole sound scene. And that's one of the things that you can do with Wavefield synthesis in the professional setup. You don't have a mix down of signals to one sound field. You already have access to the original sound sources. So you can treat them differently, and you can have them move wherever you like them to be in real time. Be it driven by a joystick or by a tracking or even automated like we do in some of the museum installations where sound sources just appear wherever they should be and they go away when they don't need to be there any longer.
Right. Effin Dunn in the chat room writes, just downloaded the app and the effect is great.
Happy to hear that. Excellent. Thanks a lot.
I love that.
We actually got more than 200 reports on this app being excellent and great. People love it. We get excellent feedback to it. And I really appreciate that because at the end of the day, usually we're in a two-step process where the brand will get all that reward, but we're just in the background. Now, Headquake is one application where we got direct reports from our direct customers. And we like that because it also helps us to improve what we do. And we learn about what customers like and dislike about our technology and how we could improve even further from where we are today.
Yeah. We saw there a second ago, for those who were looking at the video, an image from the website about the Headquake app. There you see on the left the basic control page, which Renato was telling us about earlier. And then in the middle and on the right, I guess, are playback screens that show you what you're doing, right?
The middle screen is just your choice of where you are in searching for the right music. And you see we did an excellent job here to actually get the right album views. You even have those album views on AirPlay. If you have a device that can do AirPlay, it can do Bluetooth. It can actually sort your music in any kind as you would be used to it from the original iTunes player. You can shuffle play, you can loop. You can actually take your own playlists and play your own playlists as you are used to from the original player as well. And then on the right side and the right screen, you saw the selection of different headphones set. So this will be more elaborate in future versions where you will be able to choose the very headset you bought into. And if you spend $100 or even more for a good piece of headphones, you better make them sound right by using the right filter as well.
Yes, indeed. Well, in the last couple minutes, then, I want to just quickly mention a program that Sonic Emotion has that is near and dear to my heart, of course, which is music in our schools. Because music in the schools is under such pressure and has so little funding that it is suffering greatly. And I think it's one of the most important things that schools can do, not only to help students be musical in one way or another, but also because musical training helps in everything else, math and reading and reasoning and teamwork and everything else. Tell us a bit about the Music in Our School program from Sonic Emotion.
So what we like to do is to be part of what it means to educate young children about all the emotional parts and aspects of getting music in 3D sound towards you. So whenever you put a like on our Facebook page, and please do, we will spend money on it. So 5,000 likes on our Facebook page just now, which will mean $500 towards that program. Further on, if you download Headquake, a percentage of that money we earn there will always be donated also to Help Me Hear, another program that allows children with impaired audio capabilities to actually get hearing aids or whatever they need to live a normal life in this wonderful space of 3D sound.
Wow, that's incredible. Now, are you addressing mostly European schools or U.S. schools or all around the world?
we are a global player, and we actually try to do donations to programs that are all over the place. So this very in the school thing is a US thing. However, the Help Me Here is a global donation. We help children all over the place. Fantastic.
Well, I want to thank you so much for being with us today and explaining Absolute 3D. It's a fascinating technology, and I look forward to hearing more about it in the future. And maybe you'll come back when you have some more announcements to make and be on the show again.
It was a real pleasure to talk to you. Thanks a lot for having the opportunity. Bye from Europe. Snow is still excellent down here, and looking forward to talk to you next time.
Thank you so much. That's Renato Pellegrini, the co-founder of Sonic Emotion. You can learn more about the Absolute 3D technology at sonicemotion.com. My online home, of course, as always, is hometheater.com. You can email me at scott@twit.tv, or you can follow me on Twitter at htgeekscott. Next week, as I mentioned earlier, my guest geek is scheduled to be Bob Schuline, a longtime home theater product developer with some new advancements in the field of binaural recording and playback. So I'm sure looking forward to talking with him, and I hope you will join me. Until then, geek out.